Alright guys, my name is Tyler McArthur, and today I will be talking about lasers, which is pretty cool. So before we start talking about how lasers work, I want to comment on how they're kind of special. So they produce a single wavelength EM radiation that is coherent, meaning the emitted photons are in phase. So a laser output can thus be more precisely manipulated than incoherent mixed wavelengths from other sources. The reason laser output is so pure and coherent is based on how it is produced, which in turn depends on a metastable state in the lacing material. So looking at this next slide, you can see that an atom can be kind of jumped or excited to different states. So there's first a metastable state, a second and a third, and so on. And so when energy is put into a large collection of these atoms can be jumped from different state to different state. So most atoms return to the ground state shortly after this excitement, but those in the metastable state that are jumped to the metastable state kind of stay there for a longer time. So this includes those electrons originally excited to a metastable state, and also those that go to a higher state but then fall down to a metastable state. So it is possible to get most of the atoms into the metastable state, which is called population inversion. And so population inversion causes, in this slide, we can see that most of the atoms are going to be in this first metastable state. So when they are all at this first metastable state, some atoms, or one atom in particular, I guess at one point in time, starts to decompose and de-excite. And this causes a photon that has the exact same energy and wavelength as the atom to be produced, and the photon goes on to stimulate another atom and to de-excite it. And that photon, has the exact same energy and wavelength as the first, and is in phase with it. And both go on to stimulate the emission of other photons, and so on and so on. And a population inversion is necessary for there to be net production rather than a net absorption of the photons. So basically, if most of the atoms were up here or back at ground state, there wouldn't be other atoms for the photon to run into, so there wouldn't be sort of this ladder effect happening. So laser is actually an acronym for light amplification by stimulated emission of radiation, which is the process that I just described. The process was proposed and developed, allowing the advances in quantum physics. So a couple of people in 1964, Charles Towns and Nikolay Basov and Alexander Prokhorov, were the first to develop a laser. And the Nobel Prize in 1981 went to Arthur Schawlow for pioneering laser applications, and we're going to talk about those a little later. When they first produced it, it used a pulsed high-power flash lamp and a ruby rod to produce red light. Today, the name laser is used for all such devices developed to produce a variety of wavelengths, including microwave, infrared, visible, and ultraviolet radiation. So now we're going to talk about some application of lasers. First will be CD and DVD ROMs. So music CDs are now so common that vinyl records are quaint antiquities. CDs and DVDs store information digitally and have a much larger information storage capacity than vinyl records. An entire encyclopedia can be stored on a single CD. This picture here illustrates how the information is stored and read from the CD. Bits made in the CD by a laser can be tiny and very accurately spaced to record digital information, such as these little guys right here. These are read by having an inexpensive solid-state infrared laser beam scatter from pits as the CD spins, revealing their digital pattern and information encoded upon them. So that's a little bit about how CDs and DVDs and stuff like that works. There's also laser surgery. So sometimes the eyeball has a problem staying in the socket, or the tissue around it detaches almost, or is cut and stuff like that. And doctors will actually use a laser with a certain wavelength and amount of radiation to kind of, I guess, burn the back or the affected tissue in order for it to cause scar tissue, which will then link it to where it's supposed to be. In other words, it's kind of like welding your eyeball into where it's supposed to be. So that's the application for laser surgery with eyeballs. And then there's also stuff like laser light shows and laser printers and fiber optics and different things like barcode readers at the library or the grocery store, and also missile guidance and anti-missile stuff like that also includes lasers. So lasers are awesome, and yeah, thanks for watching.